ออภัยคนที่อยู่ช่องซูม YouTube นะครับผมไปกดผิดครับมันเลยปิดไปเลยนะครับalright เดี๋ยวนะครับเขามีประชุมนะผมขอออนของno meeting flatten where is that it's this one right เดี๋ยว604จะขอเลิกชาร์จนิดนึงนะครับเพราะว่าผมเสียเวลาเซตตรงนี้นะครับ alright okay meeting what's the and Zoom เอา Thailand and yes, we have to send the link, right? Link to M605, right? The link to M605 sendมาแล้วเนี่ยโอ้ 605 yeah, this one in this one, and this one, right? 1,000 right? 605. Okay. Okay. M605, are you all right? M605. M605, are you all right? ทุกคนเรียบร้อยนะครับ605นะครับOkay, ปานทัศน์ and ธนกร right ธนกรพิมพ์ชื่อมาแล้วนะครับโอเคธนกรปานทัศน์ครับโอเคso when everything is ready I'm going มีอะไรเกิดขึ้นมีพิมพ์แชทมาตรงนี้นะครับเขียนว่าก็ธนกรมาทุกคน alright just let's move to let's share screen we need to open the file of M605 จริงๆผมเตรียมบทที่6ไปแล้วนะครับแต่ว่ายังไปไม่ถึงกันครับ alright yes I hope that everyone is already there, right? Two students, two people in the Streamlabs channel, and no one more, right? Let's go ahead with this to not waste our time. Okay, the So good morning, everyone. Welcome you to SCI33206. This is the section for M605. Okay, this is for M605. And let's go ahead with it. We have a remaining problem we didn't complete last time, right? That's the problem about sheriff, okay, or somehow like policeman and so on, and a thief, okay, which is called cattle rustler. Okay, the policeman tried to shoot this bad person, and but unfortunately the bullet has missed him, and it just hit the wall of the water tank of the town. Here, this is the water tank of the town, and once the bullet get into one side of the tank, of course, we are going to have the hole, right? And the hole here will allow the water going out. Okay, the water will flow and downward. Okay, and yeah, the question is determine the speed, okay, the horizontal speed of the, is that correct? Yes. The horizontal speed of the water that starts to flow at this location. In that's the first question. For the second question, what does the stream, where does the stream hit the ground, right? So how far the water will hit the ground, and that's our task. We have to solve this. Okay, yes, let's talk about first the speed that we get out of the hole here at the container, at the water tank. Of course, it's up to you. Let's say this is the first location, this is the second location, right? At the first location, right? At the first location, what about P1, which is the pressure at this location? Okay, this is the pressure caused by the air. It's around PATM, right? 3.102 times 10⁻²⁵ Newton per square meter or Pascal or something like that, right? Yes, we are going to have that pressure, right? And they have finished and completed the meeting already. Okay, the next one is Y1. Y1 is the height of the first location. Okay, what is that? It's Y1, right? It's the height here. Y1 is Y1. Okay, we don't know, but this one we know that this is 3 meters. That's the information from the problem, right? So Y1 is gonna be the addition of 0.5 and 3 meters, right? So you're gonna have 3.5 meters here, and next the speed at the first location. Okay, of course the water is start to fall down, right? And when the water here is bleeding, right? It's going out. This one should have also the speed, right? But assume that the tank is very, very large. Okay, when the tank is very large, we assume that when they don't talk about the information the size of the tank. Okay, we would assume that the tank is very large and the water reduction speed or the water levels flow here is gonna reduce. Okay, reduce with the zero speed. So V1 is approximately, okay, V1 is approximately 0 meter per second. All right, we assume that for simplicity. Otherwise, we couldn't solve this. They don't provide enough information.กิตภพพิมพ์ชื่อมานะครับที่ช่องนั้นนะครับแล้วก็อันนี้ก็มีพวก ordinary guy คือใครละพิษไม่ใช่ใช่ไหมพิเชษพงศ์ของ605ใช่ไหมครับไม่ใช่เนาะปัทานินนี่604ใช่ป่ะกฎชวงศ์วัดใช่กฎชวงศ์วัด605นะครับมีพระวิทย์มีพฤตินันนะครับพวกนี้นะโอเคใครจะเข้าปฏิหารนะ I'm sorry for that I didn't see you ธนกรปฏิหารนะครับ alright yes นากรปฏิหารนะครับyes who else yes นี่คนไหนจะเข้าอยู่ครับ all right yes now we have this right yes now we consider the second location, which is the bleeding side, the hole here, which is caused by the bullet. Okay, the second location at the second location. Okay. Talk about we will talk about the pressure, the height, and also the speed, right? It's P2, right? P2. Okay, actually the pressure here should be a little bit different from the pressure at location number 1 because 0.5 meter, but 0.5 meter is not a big deal, right? The height is not so significant. The height is not so significant, so yes, the height is not so significant. We assume that this one has also the same pressure. Let's say it's approximately again the same PATM. Okay, PATM and Y2. What is that? The height of the second location is 3 meter. 3 meters. V2 is the bleeding velocity. Bleeding speed is what we don't know, right? It's unknown quantity. So once you have all these 6 values, we're going to start the Bernoulli equation. Bernoulli is OU, right? Bernoulli equation. Okay. And yes, you just go ahead with the first term, right? P1 and plus rho G Y1 plus 1 by 2 rho V1 square equals P2, right? The second location plus rho G Y2 plus 1 by 2 rho V2 square. Okay, the formula is quite long, but it doesn't matter. Okay, P1 is PATM, right? PATM plus rho GY1 just leave it. Okay, we know that rho gy1 is greater than that, right? So we move rho gy2 to the left side. We get rho gy1 minus y2, and what we want to find is v2, right? So the supports are we have right here 1/2 1/2 rho plus 1/2 rho v1 square and equals, right? Please note that P2 is the same, right? It's PATM and plus, right, the remaining term, which is the 1/2 rho v2 square, right? So you have the cancellation of PATM right here, right? And please note that once you have removed first PATM terms, you would have the common factor, which is the density rho, right? Of course, it's water, it's not difficult, it's 1,000, but it's easier for us to remove this term so that our life is going to be easy. Okay, cancel rho in all the three terms. So you get g by 1 v2 y2 and v1 square and v2 square right there. Okay, you get right now g and y1 and y2 is the difference, right, which is the height here. So it's delta y, or the h, right, the height of the hole, the depth of the hole under the water level. Okay, and we get the next thing is 1/2. Okay, please note that v1 is the speed of the water flow and it's approximately 0, right? So this term just vanish. Okay, we don't need to pay attention anymore to that term. Yes, the right hand side you have 1/2 v2 square, right? And yes, you can solve it for v2. v2 is going to be the square root of 2gh. All right, you get v2 as the square root 2gh, and you know that h is the height, which is only 0.5. Okay, so v2 will be square root of 2 g 9.8, right, and 0.5. Okay, simply speaking, it's square root g. Okay, square root g. It's square root g, but in numeric way, if you want to compute it, square root of g is 3 blah blah blah. If I can't remember exactly, 3.1305. Okay, it's approximation. .1305 and meter per second. All right, and that's the first quantity, right? The second quantity is the distance here. Okay, how far does the water drop when the water reaches the ground? How far is it? Okay, how far is it? In order to deliver the answer to this problem, okay, ก่อนนะพวกก่อนพิรทัศน์นี่ห้องอะไรผมจำไม่ได้ห้อง5เนาะกฤตภพวชิรวิทย์พวกนี้นะห้อง5นะโอเค อยู่ด้วยกันมานานผมยังจำไม่ค่อยได้ all right yes yes yeah we have to determine further the motion of the water streamline here. And of course, they add to the water has the projectile motion like this. Of course, we can decompose the motion into two axes, right? Along the horizontal way and along the vertical way. Okay. The motion has two components. Okay. The first one is horizontal way. The second one is the vertical way, right? But these two components happen at the same time, right? Vertical way. Okay, let's consider the vertical way first. Okay, let's consider the vertical motion. Let's consider the vertical motion. Now we have, you know that the vertical motion is the water drop. Okay, start like that, and it's gonna move downward to the ground, right? It's gonna reach the ground here. But please note that the water drop doesn't have the initial speed at all. Okay, of course it has initial speed v2, which is what we have just got previously, 3.13 meter per second. But that's the horizontal speed. It's not the vertical speed for the vertical motion. Okay, there is only the component along the x-axis. There is no component along the y-axis. So the vertical way, in the vertical way, we don't have the initial speed for the water drop. So what does that mean? It means that uy, which is the initial speed along the y-axis or the vertical motion, is 0 meter per second. Okay, it's only 0 meter per second, and of course it would reach with the final speed vy, which is what we don't know. But I'm not sure whether we want this, we want to know this speed or not. Maybe we don't want to know that. Okay, but anyway, we know that the height here, the height of the hole is 3 meter, okay, above the ground. And what else? We want to find the time consumed for the water drop to reach the ground, and it's ผมไม่ได้เช็คว่าเสียงออกหรือเปล่าด้วยเนาะขอเช็คนิดนึงแล้วกันครับเสียงไปไหมนะครับเพราะว่าย้ายซูมมาเครื่องนี้นะครับตอนนั้นที่คณะประชุมกันเรื่องรับปริญญาครับ Okay, let me check a little bit whether it works or not. All right. Okay. เดี๋ยวขอเช็คเสียงก่อนครับเดี๋ยวคนอยู่ในซูมไม่ได้ยินครับเดี๋ยวจะบ่นผมwhere is that? This one, right? The control sound to sound output to it's real take audio. Okay, test 1 2 3 คนอยู่ที่ซูมได้ยินเสียงผมไหมครับคนอยู่ที่ซูมครับ otherwise I'm gonna get into the meeting here from this machine to check the sound. All right, video by tracing. Host last about. Yes, sir. Yes. Test 1 2 3. Okay, the sound is is great. Okay, the people in Zoom would be able to hear everything, right? Yeah. Question. All right. Oh, I'm not sure whether I shared the monitor to you. No, I didn't share the monitor. Okay, sorry for that. All right. Yeah. Russia. โอเคโอ้อยู่มาตั้งนานคนที่ในอยู่ในซูมก็ไม่บอกผมเลยนะว่าคุณไม่ได้ยินอะไรกัน anyway chat and let's look at the chat in this one, right? If possible, I'm gonna take the screen capture, right? Check ดูว่าหน้าใครพิมพ์อะไรหรือไม่ครับที่อันนี้ที่ก็มีแล้วมีคนนะเพราะว่ากดซูมมันลงมาเนาะเป็น60ครับ all right yes okay in the what is that? It's the line application and the people in here. The one in speed ยังโอเคนะthis one and this one and this one too, right? Okay. Okay, let's go again with our story. We want to know Ty, the time consumed along the vertical motion, right? We know the initial speed. We don't know the final speed. We know the distance along the y-axis in the vertical motion, right? So, of course, there are a few formulas that you need to remind yourself for the Newtonian motion, right? The motion related to acceleration, the motion that has acceleration in that, right? So the motion with acceleration, what is that? We have v equal u plus at, right? We have v squared equal u squared plus 2as, right? And you have s equal ut plus 1 by 2 at squared, right? And what you know is s, right? S, which is h whole, right? The height of the hole caused by the bullet. And the next one is the initial speed, right? U is uy, which is 0 meter per second. And the next one is, of course, we know the acceleration, right? The acceleration caused by the Earth, which is g here, the vector g, okay? The gravitational acceleration on our planet, on the Earth. Okay, we know A, right? Which is g actually 9.8. meter per second square, and we want to find ty and t, which is ty, and what is that, right? So the one that we have to choose is this one. Okay, this formula, and yes, let's substitute everything into that expression. S is gonna be, oh, I'm sorry for that. S is h whole, right? The height of the hole, h whole, and ut, unit of speed is 0 times t, of course. Ty is what we don't know. The ty, oh, I'm sorry for that. Ty touch 1/2. A is the acceleration, which is t, right? It's actually t. And t square is ty square, right? So if you want to solve this, you will get ty equal, okay, 2h whole divided by t, right, and square root of that. Okay, and yes, square root of what? Square root times 2 h whole. What is the height? The height of the hole is 3 meter, right? It's 3 meter, and here is 9.8. Again, if you put it into the calculator, you can get 0.7825. 0.7825 second, right? It's second. All right. Let me check whether it's correct or not. Yes, it's already there. And yeah, that's the result after we cause the vertical motion. That's not our target yet. We want to know the distance along the x-axis here, how far the water projectile motion is gonna reach the ground here. How far is that? So we want to find dx from the horizontal motion. So let's consider the horizontal motion. All right. Let's consider the horizontal motion. So what is the initial speed? Of course, the water drop is start like that and it stop. Here is only the x component, right? It's gonna reach like this. It start with ux as v2, right? Which is here 3.1305. 3.1305 meter per second. And the final speed. What is the final speed? It should be the same because there is no acceleration acting on this water drop at all. Along the y-axis, there is no force acting on to the water drop. So there is no force acting on the water drop. So x is 0. So we don't have to deal with the Newtonian formulas. Okay, we just substitute a as 0. This one, right? If you substitute a as 0, you get s equal to ut, right? You get s equal to ut, and that's the basic formula of the speed, right? And yes, you want to know dx, right? The distance along the x-axis for this motion, right? So dx will be u, the speed, which is 3.1305, and T is time 0.7825. Yeah. You get dx approximately right there. Right. And if you don't want to go ahead with that, it's dx. I'm sorry. Is the product between velocity, right? Velocity is square root g. You can see here it is the square root of g, the gravitational acceleration on Earth. It's the square root of g, and t is the time, right? The time consumed by these motions. It's square root 2h divided by g. Square root of 2h whole, the height of the hole, divided by g, right? You could see that g can cancel even inside the square root. They can cancel each other. We're gonna get finally square root of 2h whole, right? 2h whole, and it's actually square root of 2 and 3 meters, right? The height of the hole. Square root 6. What is that? Square root 6 is anybody who can remember. Is there anybody who can remember the value of the square root 6? Square root 6 is 2.4495 meter. Okay, and that's it for our problem. Okay, the distance here. The distance here is approximately 2.45 meters, okay, away from the hole or the wall of the container, the water tank. All right, and that's the way we could find that's the way we could find the distance, okay, along the x-axis. Now let's move to the next problem. Okay, the next problem is somehow this, right? We have three problems to the Bernoulli's equation. Okay. Here we have a pipe like that. Okay, that is a pipe, and yeah. The information of this question is somehow like that. Let's take a look at this. Okay, you have an input side here. This is the output side. The water flow into this pipe. Okay, and the water will get out of this pipe. And you know, this is the bigger cross-sectional area. This is the smaller cross-sectional area. And of course, the water should have its own velocity, which is denoted by V2. The water out of this side should have its own velocity, which is denoted by vector V1. This is the first location. This is the second location. If you want to comply with the Bernoulli's equation, is valid for summation of pressure at different locations. But here we have two locations, number 1 and number 2. Okay. Now let's get into the information of this example. A large pipe with a cross-sectional area 1 square meter. So this A here. This is the large pipe. A2 is 1 square meter. And this is it's gradually decreasing. Yeah, it goes in the decreasing like this, like in descent way. 5 meters. So this is 5 meter. The height here is 5 meters. Okay, it doesn't matter how shape it is. Okay. And it goes down to narrow to 0.5 square meters. So A to A1, which is on this side, is 0.5. square meter. Okay, 0.5 square meter, and it terminates in 1.1. Okay, yeah, of course, it is a kind of type. Okay, the valve has a lower cross-sectional area. Okay, in order to control the water flow, right? แล้วบินนะเพิ่มทำไมนะครับ Okay, yes, let's go ahead. มีใครเข้าที่ซูมนะไม่มีแล้วนะ yes, let's go ahead with that. The pressure at point 2 is atmospheric pressure. So pressure here is P0 3.120 3.01 blah blah blah. I cannot remember atmospheric pressure. It's P0, and the valve is open wide, and water is allowed to flow freely, so the water can flow easily without any restriction. And yeah, they say also P0. Yeah, the pressure at this location is subject to also the atmospheric pressure P0. All right, and find the speed of the water leaving the pipe. So what is V1 at this location? Okay, V1 with our vector is the magnitude. V1 with the vector with the arrow on top is the vector version. Okay, it has also direction. And if you take a look at this, you can see that this is the symbolic meaning of this figure. The vector here, the red one, the red arrow, has the length like this, and V1 has a long length, okay, like that. So let's go ahead with that. Yeah, the first location and the second location. At the second location, you have P1, right? Oh, sorry, P2, which is P0, and it is PATM, right? And Y2, the height of Y2 is 5 meter. I don't know, but the difference between these two, right? I don't know. And V2, velocity V2 is also unknown, right? What about at the first location? What about the first location? At the first location, at the first location we have P1, right? Equal P0 and equal PATM, right? The atmospheric pressure. And Y1 is the height at this side, right? So Y1 equal unknown. Okay, we don't know we don't know the height of this one, right? And V1, the output speed, that's what we want to know. Okay, they ask us to find V1 here. So let's open the next page in let's take a look at the Bernoulli equation. Bernoulli equation. Bernoulli equation. Okay, Bernoulli equation says that P1 plus rho G Y1 plus 1 by 2 rho V1 square equal P2 plus rho G Y2 plus 1 by 2 rho V2 square. Okay, and of course both P is equal to P ATM, right? And you then have If you move this term to the left hand side, you're gonna have rho G y1 minus y2, right? And yeah, we have the second term 1/2 rho v1 square equal the right hand side here is also PATM, right? PATM, the pressure at the atmospheric level, and plus 1/2 rho v2 square 2, right? The last term. Yeah, we could cancel PATM on both sides. And of course, this is the common term. There is a common term. Rho, we could cancel rho in this equation, right? You know that y2 minus y1 is actually h, right? This one is h, and it is 5 meters. Okay, it's h actually. So you get G, H, and R plus 1/2 V1 square equal 1/2 V2 square, right? If we multiply the whole equation by number 2, so we get 2GH plus V1 square equal V2 square. But our target is V1 square, so V1 square will be V2 square minus 2GH, and that's it. We could not do anything more, right? We keep it as the first equation. That's the result from Bernoulli equation. Okay, once we try to leave every term into that. Okay, let's go ahead with that one. We don't know also the velocity at the input side V2. Okay, there are two variables V1 and V2, but we have only a single equation. Is it possible to solve this system? No, it's impossible, right? We need to have one more equation so that we can solve two equations for two variables, right? So which equation should we call for? Which equation should we do in order to solve this problem? Yeah, we will recall the continuity equation. Continuity equation. Bernoulli equation has already been used, right? Continuity equation says that the volume per time, right, the flow rate of the fluid per time is equal to the cross-sectional area at the first side times the velocity of the fluid at the first side, and equal to the cross-sectional at the second side times the speed at the same side. We get that, right? But our target is V1. We're gonna find the expression of V2. Okay, so that we can substitute V2 into the equation number 1. So V2 will be A1 by A2 times V1, right? We substitute V2 into this expression, right? Yes, on the left hand side. On the left hand side, you're gonna have okay. On the left hand side, we have V1 square equals V2 square, right? It's gonna be A1 by A2 A square, right? And V1 square 2, right? And minus 2GH, right? In order to solve this one, we move 2GH to the left hand side, we move V1 to the right hand side, so we get 2GH equal A1 by A2 square minus 1, right? n times v1 square, something like that, right? Yes, we would move this coefficient to the left-hand side so that we get v1 square. So v1 square will be 2gh divided by a1 by a2 square minus 1, right? Yeah. Let's substitute that. Okay. So v1 will be square root of 2gh a1 by a2 square minus 1, right? Oh no. Let's go ahead with that. v1 will be square root of what? Square root of 2 9.8, and the height here is number 5, and you have here a1 what is that? A1 is cross-sectional area, right? A1 is 0.5. 0.5 by A2, which is number 1, and we have that minus 1, right? It's going to be imaginary number, right? 1 by 4. Yeah, we could not find it. My God. Because A1 by A2, A1 is less than. Is that correct? I think V2 will be, yeah, we don't want to know V2 is like this. V2 is A1 by A2 times V1, and V1 square will be A1 by A2 square. Yes, you move it to the left hand side. You get a positive. Why? Y2 minus Y1. Yes, I know. This one is incorrect. Y1 minus Y2 is not h, okay, it's negative h, negative 5. So this one is negative 2gh, this one is negative 2gh, this one, once you move to b here, it's going to be positive. And on the right hand side, you get positive here. Move to the left hand side, it's negative. And you have the negative here again. And of course, negative. And it's better to not have negative into that. And we write it in a different way, in the opposite, in a reverse way. 1 minus A1 by A2 square, right? So 1 minus A1, which is 0.5, 0.5 square meter divided by 1, which is the cross-sectional area of the second location, is square, right? And you leave it into the calculator. Okay, you leave it into the calculator, and you get where is that? Okay, square root 2 times 9.8 times number 5 and 1 minus 0.5 square. Yes, get 11,431. 11.431 meter per second. Okay, that's the speed of the water getting out the speed of the water getting out of this side by the output side. Okay, we get 11.431, and now let's move to the last question. Okay, last question right here. Okay, ขออนุญาตเข้ามาครับจบสำหรับข้อนี้เหลือข้อสุดท้ายครับแป๊บนึงครับเดี๋ยวมาครับ Okay, let's continue our story. Right? Yes, we arrived at the last example of the topic bandwidth equation, right? The topic of bandwidth equation. It's quite close to reality, right? You know that in physics, you will deal with the problem that is really close to our real life situation. Okay, water enters a house through a pipe with an inside diameter of 2 square centimeter at a gate pressure. This is the absolute pressure, I think. Yes, 4 times 10 to the 5 Pascal. Okay, only this quantity is not in the SI scale. Okay, it's 2 centimeter. The cold water pipe leading to the second floor bathroom 5 meters above is 1 centimeter diameter. Okay, as in figure 70. So let's try to understand this scenario. Okay, if you live in a town and if this is the street, under the street, there's the authority would provide a water pipe, okay, from the town to your house. This is the inlet pipe. The water will get into the water will get into this pipe, okay, and you can use the water for any purpose, okay, up to you, as you like. Okay, and yes, once the water get into this, the water will be separated into two portions. The first one is going directly to your tap, your washing place, okay, to wash the dish, to wash the glass, and so on. And this the water which is supplied to your toilet, to your bathroom, and another portion of the water is sent to this device. Okay, this how located in a cold area like in the United States of America, because it's the original source of this figure, or in the European continent. Okay, you are living in a cold water. You need to make the water warmer by using the hot water tank. Okay, it's also the pump together with the boiling process here. Okay, to make the water hotter. And then hot water is applied to several places inside the house. Okay, and that's the whole system. And the difference between the first floor and second floor is 5 meters away, and the inlet side has has 2 centimeters in diameter. Okay, this is the inlet pipe, and inside the house they use a small pipe which has only 0.5 centimeters in diameter. Okay, and the first question to this problem is the following. They want to know find the flow speed, okay, in the bathroom. Yeah, okay, and the gate pressure in the bathroom. They want to know the gate pressure at the pipe, this location in the bathroom. Okay, now it's time to solve this problem. Let's draw over a new page here. All right. We want to know the water speed, which is V2, right, and the bath here. So find V2, right? What is V2? We need to use the continuity equation. We assume that there is no water leak at all inside this house, so the continuity equation is valid. Okay, the water cannot be compressed in terms of volume, right? So we're gonna use the A1, V1 equals A2, V2, right? And we would be able to find V2 from this ratio A1 by A2, and something like that, times V1, right? And yes, of course, A1, as you know, A is the cross-sectional area of the pipe, which is circle, right? So pi r square, right? You get pi r1 square at the numerator, and you get pi r2 square at the denominator, and V1 here. All right. And yes, V2 will be, of course, we get the cancellation pi, right? And we get R1 by R2 square here times V1, right? R1 is the radius at the inlet side of the location number 1. It's 1 centimeter times 1 times 10 raised to number 2. Right, and at the output in the output side location number 2, you get 0.5 times 10 raised to negative 2, right? And times V1, which is the speed at this location. They say here that the flow speed at the inlet pipe is 2 meters per second. So you have here number 2. All right. And of course, you get cancellation here, and 1 by 0.5 is number 2. Right. And sorry for that. You should have also number 2 as the power. Sorry. Yes. Yes. You have number 2 right here. Okay. 2 square times number 2. It's equal to 8 meters per second. Right. And that's the first quantity you could deliver to the first sub question right here. Okay, find flow speed. The flow speed is known right now 8 meters per second at the bathroom. Okay, in the bathroom. And gate pressure, the absolute pressure in the bathroom. So let's continue this derivation. Yes, of course. Let's take a look at the Bernoulli equation. The tool for us. Bernoulli equation. Bernoulli's equation. Yes, of course, we have Bernoulli's equation. We have P1 plus no, it's potential. It's rho G Y1 plus 1 by 2 rho V1 square, right? And equal P2 plus rho G Y2 and plus 1 by 2 rho V2 square, right? Yes. Of course, you know that the gate pressure at the inlet side, they say the gate pressure at the inlet side is 4 times 10. Okay, they say P1 equals 4 times 10 to 5 Pascal or Newton per square meter, right? You know this value. And they want to know P2. So we know P1 with this amount of pressure. We want to find P2. So we move every term to the left hand side. Right? Of course, P2 right. So yeah. We would get P1 in the first term. And plus rho G Y1 minus Y2, right? And we get also plus 1 by 2 rho V1 square minus V2 square. Okay, we move these two terms to the left hand side. And P2 is going to be P1, which is the gate pressure. Okay, let's say it's still P1, right? Plus rho G Y1 minus Y2. What is that? The height of Y1 minus Y1. We know that Y2 is greater than Y1, so this term is negative. Actually, this term is negative. Negative of what? Negative of the height here, which is 0.5, right? So, which is 5.0, and plus 1 by 2 rho. What is that? V1 square is 8. Oh no. V1 square. I don't know. So V1 is 2 meters per second. So this one is actually incorrect. It should be negative. Right? It's negative. And, because V2 is greater than that, so we're going to leave the bigger term at the first location. So at the first position, V2 square minus V1 square, right? So now we have P2 like this. P2 will be P1. What is P1? It's 4 times 10 to 5, right? 4 times 10 to 5 minus rho is 1000, G is 9.8, H is the height, which is number 5, and minus 1 by 2, rho is 1000. Sorry for that. And V2 square is 8 square minus V1, which is the inlet speed, is 2 square, right? You leave it into the calculator. Okay, you leave this into the calculator. You get, I don't know. Let's take a look at the calculator. It's 320,500. It's Newton per square meter, right? It's the pressure per square area, right? Per area. So in terms of Pascal, you would get 3.205 times 10 to 5. Okay, and Pascal. Okay, and that's it for the gate pressure here. All right. And yes, of course. They want to know how much time would be. Let's move to the bigger figure here. Okay, how much time? What time is it? We still have 6 minutes left. Okay, let's go ahead with it. How much time would be required to fill 100 liter bathtub, right? Bathtub. Just if you want to lay down inside your bathroom, right, you need the water of 100 liter, okay, into that, like a jacuzzi or something like that. Okay. So they want to know how much time. If you open the water tap and you need to wait, right? You may go to do, you may go somewhere else to do something. Okay, and you don't have to wait for that. And yeah, use the physics to calculate, determine how much time you're gonna wait for the water to be fully filled in that bath. Okay, so this question asks you about time. Okay, what is that? Which means you have to deal with the water flow rate, right? Water flow rate in terms of volume, right? Because they ask you about 100 liter of water, so it's delta V by delta T, right? Okay. And as you know from the continuity equation, let's get back to continuity equation. Continuity equation again. You know that delta V by delta T equal A1 V1. Oh, what's something for that? There is no ratio. A to V2, right? But here we are dealing with location number 2. You may also use A1, right? It's up to you. And A2, V2 too, right? So delta T is our destination. We want to get delta T. You just move delta T to the right hand side and move the product of A2 and V2 to the left hand side. Okay. And delta T is going to be delta V by A2 V2, right? Because we are considering the water in the bathroom, location number 2 here. Okay, let's move right there. Okay, yes. Delta V, of course, it's 100 liter. But what is liter in SI scale? 100 liter is 100 liter is 1 times 1,000, right? It's 1,000 cubic square cubic centimeter, right? If you want to convert it to the SI scale, it's going to be, what is that? It's 100 times 10 3 and times 10 raised to negative 6, right? That's the unit of the volume in SI scale, right? So it means you have one. What is that? 0.1. Okay. Only 0.1 cubic meter. That's the water in your jacuzzi or bathtub. All right. So what is A2 in this location? A2 is pi r2 square, right? And you know this is only 0.5 centimeter, so it's going to be 0.5 times 10 raised to negative square centimeter, right? Radius, right? So negative 2 meter square, like that. And V2, of course, V2, the speed here, as we know before, it's 8 meter per second, right? 8 meter per second. And yes, if you substitute everything, right, into this equation, you could get delta T, right? Delta T will be, where is that? Delta V is 0.1 cubic meter, and A2 is like that. It's pi. Okay, pi and 0.5 times 10 raised to negative 2 and square, and V2 is 8. Okay, delta T equal 0.1, like that, right? You have to put everything into the calculator and get time. 0.1 times pi times 0.5 e minus 2. That's R, right? Pi square. That's the area. And times 8, right? You get 159. 159.15. Okay, approximately. Yes, and the unit is in standard, right? In SI unit, it's second, right? And if you want to know it in minutes, it's around what is that? Divided by 60 seconds. It's around 2.65 to 6 minutes. Okay, minute. All right, and that's it for this example. We have completed this chapter. Okay, this chapter is finished at the story about Bernoulli's equation. And next time we are gonna start with this chapter, the new chapter. M604 didn't complete this example yet. Okay, they still have some time about the calculation of time waiting for the water filling into the bathtub. Okay, actually I have prepared the slide for the next chapter with atomic physics, but we are running now out of time. Okay, let me send you again the screen capture about your appearance in the class today, right? ขออนุญาตส่งอันนี้ให้อีกรอบนะครับว่าใครเ เป็นอย่างไรนะครับ this one and this one too, right? Andนะครับถ้าใครมีหรือไม่มีอย่างไรก็โปรดพิมพ์แจ้งมาเสียนะครับ alright okay we have to quick direction right now. Okay, see you on Wednesday. There's nothing change. Okay, if nothing happens, we need to continue our lecture on next Wednesday. Okay. If you have any question, just let me know. If not, then we're gonna quit this meeting, this classroom right now. Okay. Bye bye ครับสวัสดีครับ